Hey guys, I am Mansoor. Welcome to our YouTube channel, The Coders Bridge. Today we will be not seeing any technical topic in our deep learning playlist. Rather than we will be seeing the techniques and tips to learn deep learning in an easy and quick manner. A few weeks ago, I started my deep learning playlist, and 2 days before, right, I got a ping from or DM in my LinkedIn profile from a person. Like he is asking me the um, techniques and how many days it will take to learn deep learning, and what are the important topics are there, what are the interview questions and many things. So I thought, like, why should I make a video on this? Like, it will be helping many other people as well. So today we'll be seeing the different topics to be learned in deep learning and what are the ways we can learn in deep learning. Okay, so please stay with us until the end of the video. If you haven't subscribed to our channel, please do subscribe and hit the like button if you like our video, and follow us on Facebook as well. Okay, let's jump into our video. Okay, guys. So here, this is a simple architecture I have created to learn the end-to-end deep learning. If we want to master ourselves from zero to hero in our deep learning playlist. Okay, so even I personally, when I started learning deep learning, right, even I followed this particular architecture, and it helped me very um, like a big thing to me. Like, I followed this complete architecture, and today, like, I can create a deep learning model with the help of all these things without referring any document or any other things. Okay, so let's start. First thing, we want to know what is deep learning. So that is a very basic. Why, like, all the industry, like all the AI industry is transferring their models from machine learning to deep learning. What is the drawback in machine learning? What is the drawback in deep learning? Why we are coming with deep learning model when we already have machine learning models? Okay, so we need to first know the basic difference. So for that, I have already made a video, my first video. So please do watch it. If you haven't watched it, I will be giving the link in the I button. Okay, so then the next thing is we need to know what are the different types of deep learning models, or we can say neural network models we have. Excuse me. So we have three different types of neural networks, which is artificial neural network, convolutional neural network, and recurrent neural network. So normally artificial neural network is normally a fully connected or a dense layer neural network. So here we will be in normal artificial neural network, like, there will be no other confusion like transfer learning and other things and all, as we have in CNN and RNN. There is a direct how to say, we can say it's a straight model. So we will be getting input, we will be training our model, we will be deploying our model. It's a very straightforward neural network. And when we come to our convolutional neural network is used to classify, like, mainly is used to classify images. Okay, sometimes we can use convolution neural network with computer vision to, like, how to say, to classify images in videos, real-time images, and in many things. Okay, and in RNN is used to, like, mainly solve time series problems. And we can also say, like, it is used to, um, like, solve text. Normally we have, like, NLP, natural language processing. So even we can, like, create a, how to say, a sound speech analyzer by using RNN. So we have many other applications in RNN as well. Okay, so now we'll see what is the basic thing to, like, how can we learn this all this thing, and what are the basic of all these things. The normal basic thing is, what is activation functions, what is optimizers, what is loss functions, what are weight initialization techniques in neural networks, what is dropout layer and why it is used, what is global minima and local minima, and what is gradient descent and exploding gradient descent. And then padding will be going in RNN and CNN, so you can just consider for this too. Okay, first I will come from this first thing, activation functions. As I told before itself, right, we have covered an entire like video of activation functions. It's like a triggering a neuron. Okay, for that we will be needing activation functions. We have different days of activation functions like sigmoid, relu, tanh, and softmax, wish, relu, leaky relu. So we have n number of activation functions. So I have already made a video, so please do watch in my playlist. And optimizers, So we have different kinds of optimizers like gradient descent, stochasticated gradient descent, mini batch gradient, stochasticated gradient descent, Adam optimizer, ADA-GAD optimizer, ADA delta. So we have n number of optimizers as well. Okay, then come to our loss function. Loss function is of how to say, like we have different types of loss function. So based upon our input and based upon our problem, like if we are like using any binary classification, we will be going with binary cross entropy as a okay, loss function as a binary cross entropy. If we are using any regression problem, or if we are using any multi classification problem, so for that we have multi, like sparse categorical cross entropy, binary cross entropy. Okay, so we have n number of loss function as well for that. And weight initialization. What is weight initialization? How, like we have two different, like He uniform, Grot uniform. So we have many weight initialization technique as well. So as I covered in my deep learning playlist, right? So why we need to update weights? To minimize the loss and increase the accuracy, we will be updating weights in each epochs of front and back propagation. Correct. So in that thing, what are the algorithms we use in weight initialization? So that we will be seeing. And what is dropout layer? Dropout layer is nothing but, so if we are taking 100 layers as an input layer, we will be dropping some 10 how to say, we will be dropping some 15 or 10 parameters, like, or 10. So 100 is our input parameter, so we will be dropping some 10. It will be, we will be taking 90 to predictor output. Okay, so it will be increasing our accuracy. So that is a dropout layer. So what are the techniques and how to, what is the math intuition behind our dropout layer? And the next thing is global and local minima. What is global minima? What is local minima in our gradient descent? Next thing, so as we saw in our softmax activation function itself, what is gradient and whatever it is, vanishing gradient problem and exploding gradient problem. When we get vanishing gradient descent problem, when we get exploding gradient descent problem. And next thing is padding. Padding is nothing but we will be adding an extra layer. So just consider our images of some 3 cos 3. Okay, so it will be giving 3 cos 3. So when we are taking like predicting the image, our output will be coming as some 2 cross 2. Okay, so we need the exact shape of our input as an output as well. So for that we will be using padding in our images. Okay, so we have different padding, like same padding, 2 cross 2 padding. So we have many different kinds of things. So we will be seeing all these things. So what I'm trying to say is, so these are the basic things which we will be using in all the neural networks, like whether it may be ANN, CNN, or RNN. So I have covered what are the different types of neural network, what is neural network, what is activation functions, different types of activation functions. So we are in this stage. So we are yet to cover optimizers, from optimizers to the deployment part. Okay, please stay with us. And first we'll complete our ANN. So once we know what is ANN, we will be going with activation functions, optimizers, loss, weight initializing, and blah blah blah. Okay, so once we know all these things, we are good to deploy our ANN model, because ANN is a straightforward model. So there will be no transfer learning technique, there will be no object detection, there will be no object segmentation, nothing will be happening there. So it's a straightforward technique. Okay, so once we know all these things, so I have already covered this all topics in our machine learning playlist as well. So who have joined in our machine learning playlist, they will be knowing the entire technique, like what is activation functions and other stuff. So even I'm already covered this, so I'm also covering this in our deep learning playlist as well. So please do watch all these videos. Okay, so now we'll come to our CNN model. CNN model means CNN, right? As I told, right, it's used mainly used to classify images. So images will be in n number of direct, what is that shape, n number of zoom in ratio, zoom out ratio, and how other we can say, like it may be in black and like black and white color, so whatever it may be. Okay, so this again for CNN, this will be the base. We need to know what is these functions, optimizers, laws. And next thing is object detection and object localization. We can say this object detection and object localization is mainly used in computer vision problem. So I have included here, but this is mainly used in how to say, computer vision. Localization is nothing but, so just consider there is one image, just consider there is one dog in a park. Okay, a dog is running in a park or dog is sitting in a park. Okay, so our model, as per object localization, like it will create a boundary box for the particular dog with a label. this is dog. Okay, that is called as object localization. Object detection is nothing but the model will predict whether it is a dog, whether it is a cat, whether it is a cow. Okay, so that is object detection. Next, transfer learning. What is transfer learning? Like why we need to learn transfer learning in our deep learning models? Okay, transfer learning is nothing but normally we'll take an example. So if we are working in a team, so just consider we are working in some web application development as a team. Okay, so person A is developing some front end like homepage of the particular thing, and person B is working on the how to say settings page or logout page or exit page, something is working. Okay, so the there is one button called username, or so there is one field, or there is we can say like there is one title bar. In the title bar we have some button called as logout or home or something, so that particular functionality will be common. So whoever working in any of the page, they can be used that just by calling their what is that class or object or function, right? So there is no need for every page they need to create they need to write a program to how to say functionality of that button. So just once it is created, they can be called in anywhere. So transfer learning is also same thing. It is a predefined or pre-coded or pre-trained model by different organizations like Oxford University, Microsoft, Google. Okay, so they have already pre-trained our model with n number of layers. There will be something around 4096 layers. So it is very impossible to run in our machine because it is very computationally expensive, and mainly it will take months and years to run in our machines. Okay, those are pre-trained models, and we are just going to import that model, and we'll be calling that model to get higher accuracy. So normally if you want to train a image or CNN model, just consider if you want to just define whether it is a cat or it is a dog. Okay, or we are classifying whether it is what is the breed of the dog. Okay, we have many breeds of dog like retriever, shepherd, pit bull. So we have n number of breeds, right? So our model needs to predict whether as we are giving an input, it needs to predict whether it is a pit bull or it is a retriever or it's a Pomerian, whatever it may be. Okay, so for doing that we will be writing lines of code, right? We will be writing the convolutional layers, we will be introducing our max pooling layers. Okay, so there will be n number of convolutional layers with different filters, and then what we'll be doing, we'll be flattening the layer, and we'll be creating a fully connected layer. So by this we will be creating a model, then we will be compiling our model, then we will be fitting our model for 300 to 500 epochs. Again, it's a lots and lots of work, right? So instead of doing that, we have like it's a piece of cake, right? Just import one library, sorry, yeah, import one package and just use that package in our use that function by just passing our parameter and the shape of our image. Simple, right? So let's see what are the different types of transfer learning we have in CNN. So we have different type of transfer learning techniques like ResNet, VGG, SqueezeNet, AlexNet, and DensNet. Okay, so ResNet have nearly like a number of versions like ResNet 50, ResNet 110, ResNet 1120. So like we have n number of versions of this. Even for VGG 16, we have VGG 16, VGG 16, VGG 16, VGG 19. So we have n number of versions for all the transfer learning techniques. Okay, transfer learning is nothing but in a simple manner, it's already built model or trained model in n number of images. We are just calling and passing our image. Simple. Okay, then we can come like a different version of CNN, which is RCNN, fast RCNN, faster RCNN. So initially like fast like RCNN created, then there were some drawbacks. They come to a newer version which is fast RCNN. Again they came to a newer version which is faster RCNN. It sounds like some grammar class, right? Faster. And then we have like SSD, then we have YOLO. So we have a number of techniques in our what is this CNN as well. And then we'll come to our deployment model. Okay, deployment is like nothing but normally we can deploy our model in Azure, we can deploy our model in AWS. Okay, so there are many possibilities of deploying our model, correct? So we will be seeing, so I will be creating a separate playlist for deployment itself, how to like create a EC2 virtual machine in our Amazon Web Services, and how to deploy our model in Windows machine, Ubuntu machine, or Linux machine. Okay, so we'll be seeing that not so soon. So first we'll complete all this technical part, and we'll be seeing that in our end. Okay. Mm, so this is CNN. CNN. So let me conclude what is the entire part of CNN. First, we need to know why we need to go for CNN, and we need to know like these are the dependencies. What which activation functions we need to use, which optimizers we will be using, and for which type of classification we will be using which type of loss functions, and what is the weight initialization we will be using. If we need dropout layer or not. So global and what is global and local minimum. So if we are using this activation function, whether we will be facing exploding gradient descent or vanishing gradient descent or not. So if we want the same input size as an output as well, we need to use padding. So once we know all these things, so we can able to successfully detect or localize our object as a model or okay. So and again we will be like able to use transfer learning. In transfer learning there is no tension of entire thing, right? So this all will be covered in transfer learning itself. So transfer learning is nothing but just we will be going to just consider we are importing VG16. We will be going and writing from what is that TensorFlow. We will be importing VG16 application.vg16, and we will be just calling vg16 model is equal to vg16, and we will be passing our parameters like this are input parameter, this is our dimension, this is our size, and it will be like returning the what is that predicting confidence. Okay. And then we need to learn. So there's some advanced thing, what is RCNN, CNN, and this thing. And then after completing all this thing, now we have a handy model in our hand, like a model which is working model. Okay, we can say it as a working prototype. Okay, so once the working prototype is ready, we will be deploying in model by using Flask in AWS or like Microsoft Azure. Okay, so this is like how to say a conclusion of CNN. So now we'll go to RCNN. So sorry, not RCNN, RNN, recurrent neural network. So recurrent neural network is mainly used for time series problem. So I can give you an example. So like if you just go to what is that, our Gmail box, or how to say, we can take a Gmail as a example. So if you are writing an email, right, you are writing an email to your boss, like as I am like how sick today, I will be unable to. So you will be writing unable as soon as like it will be showing you like offers. It's a how to say, it's a suggestion, text suggestion model. So even that in that place we are using RNN, correct? So how our model is finding whether we need to like suggest him office, suggest him park, suggest him movie theater based upon our previous content. So you are writing to your boss, it as I am unable to come to office, like as I'm sick I will be unable to, like you are writing an official how to say a permission or request letter, right? So the RNN model is so much capacity, has so much capacity to understand the emotional vector. So each like word has each own emotional vectors, right? So based upon that, it will be suggesting you. So for this thing, you need to how to say, like our model needs to keep the memory of our old how to say letters as well. So first you will be writing, right, as I am sick. So when our model is so you are writing as I am sick, I am unable. So when our model is encountering unable, it wants to remember the sick and as both. Okay, if our model is able to understand our previous conversation, then only it can predict you the next sentence, right? Okay, so for this thing we will be using LSTM. LSTM is nothing but long short term memory. Okay, so we have different types like in RNN as well. So long short term memory, bidirectional LSTM, and graded recurrent unit. So this we will be seeing when we are coming to RNN. So my favorite, this is one of my favorite topic, LSTM, because I personally like NLP very much. Like I have done many own projects in LSTM as well. So I will be just showcasing this as well when we come to our RNN playlist. Okay, so again in RNN we have transfer learning. For RNN transfer learning, we have word to vec, globe. So when we are doing word embedding, right, word embedding is nothing but we will be like just consider like we are predicting our how to say a movie review. So just consider we have some IMDb. We all know it. What is IMDb? It's like a movie review portal. So in that, based upon the comments of our users, we need to predict like how this movie, what kind of rating we can give to this movie, right? So a person has written like this movie is fantastic, and my family enjoyed while watching this. So our model, based upon our word memory, our model needs to encounter each and word and needs to understand the emotion or sentiment behind our word. So even we can say sentiment analysis for this. Okay, so we have many transfer learning techniques like word to vec and glow. We will be seeing what are these tools. And again, so after knowing transfer learning of RNN, so we are good with RNN. So now we know what is RNN, what are the optimization activation functions we need to use in RNN, and how to say, what is the new features of RNN, which is LSTM, long short-term memory, by like bidirectional long short-term memory, GRU, which is nothing but graded recurrent unit. So what is this? So once we know all this, we are good to create a model by ourselves. Okay, so once we able to create our model by ourselves, we want to use our pre-trained model, which is already available in a market, which is work to vec, glow, and many others. Okay, even we are like good with that, we will be going with the deployment of our model. Okay. This is the simple thing, techniques how to learn deep learning. So when you are seeing it first time, right, it will be very complex and words will be it's very bit difficult to understand. But trust me, when you start learning, right, you will be like like having like great fun when you are learning, because deep learning is a play. Like even myself, right, I myself, when I was machine learning, I was very bit bored, so I will just read for 2 hours and I will just go out. So my mind is literally frustrated when I was learning machine learning. But when I started learning deep learning, computer vision, NLP, and all, right, I'm very active and I'm really interested like what it will be next, what I'm going to learn next, what problem can I solve today. So deep learning is a very interesting topic. So as I have started the basics and theoretical part, as I told in a previous video itself, theory is very important. Max knowledge and statistic knowledge is very important in our deep learning. So without the base knowledge, if you are just going for any interview, like if a person is asking what is optimizer, what is activation functions, why we want to use activation functions, like activation function, we will be calling in our how to say, just consider we are using some ANN problem. Okay, so we will be calling model dot dense layer. So we will be giving our input and we will be calling activation function is equal to ReLU. Okay, like we need to type their activation function is equal to ReLU, activation is equal to ReLU. So you don't know what is the use of giving that there, and what is the math behind it, how like the ReLU will be performing in backend. If we, instead of ReLU, if we give sigmoid, what it will be happen, whether our model will become more accurate or it will be giving us more loss. Okay, for entire thing we need more knowledge on the math intuition behind all these things. So in our next session I will be covering what is gradient descent, and then we will be seeing what is gradient, vanishing gradient problem and exploding gradient problem. Then we will be starting our playlist with optimizers. Okay, so once optimizer is done, we will be seeing different types of loss functions, and then what is global and local minima. Then we will be going with weight initialization technique, and then we will be seeing dropout layer. So once rather than this padding, once all this part is completed, we will be creating our first artificial neural network practically, and we will be deploying the model in Amazon Web Services as well. Okay, so just cross your fingers and start learning everything. So it will be just big boom when you just deploy your model, or when you predict like when your model is giving some 90 plus or 95% accuracy. You like, I really say, right, you will really enjoy this complete playlist. Okay, so please support us by liking our video, subscribing our channel, and sharing the videos with your friends who is interested in learning our AI techniques. Until then, thank you. Bye bye.